Hello, this is not your chem tutor, and in this video, I will teach you how to solve parts per million or ppm. Parts per million is one of the many expressions of solution concentration. In this video, I also included examples so you can practice some calculations. In order to answer problems about parts per million, you should know how to perform dimensional analysis, especially in converting units. If you are not familiar yet with dimensional analysis, you can check the description box. I put there a link to my video. Let's proceed to the formula. Parts per million or ppm has two formulas. And the formula you are going to use depends on what is given in the problem. If you are given the mass of solution, then you will use the first formula. ppm is equal to mass of solute divided by mass of solution times 10 raised to 6. Now, students usually ask if there is a specific unit for mass of solute and mass of solution. The answer is none. You can use any unit of mass. You can use grams, kilograms, or milligrams as long as you are consistent with that unit. For example, if you are using grams for mass of solute, then you should also use grams for the mass of solution. If you are using kilograms for the mass of solute, then use kilograms as well for the mass of solution. Again, you can use any unit of mass you like as long as you are consistent with that unit. I want you also to take note, I have also mentioned this in my video about mass percent. Mass of solution is equal to mass of solute plus mass of solvent. On the other hand, if you are given volume of solution, then you will use the second formula. ppm is equal to mass of solute divided by volume of solution times 10 raised to 6. Unlike the first formula, the second formula requires a specific unit. For the mass of solute, the unit you must plug in must be in grams, and the volume of solution must be in ml. Example 1, a 50-gram solution contains 0.00200 grams of MgCl2. What is the concentration of MgCl2 in ppm? In this problem, we are given the mass of solution, which is 50 grams. So we will use the first formula. So ppm is equal to mass of solute. Our solute is MgCl2. So the mass of our solute is 0.00200 grams. Divided by the mass of solution, which is 50 grams, times 10 raised to 6. So 0.00200 divided by 50 times 10 raised to 6, this is equal to 40 ppm. And this is the answer to the question. Example 2, 0.175 grams of NaBr is dissolved in 200 grams water. What is the ppm concentration of NaBr in the solution? So in this problem, NaBr is the solute and the solvent is water. So always remember, the solute is the one being dissolved in the solvent. So we will solve for the ppm, so still we will be using this formula. So ppm is equal to the mass of solute. We are given 0.175 grams. So 0.175 divided by the mass of solution. In the problem, we are not given the mass of solution. Instead, we are given the mass of solute and the mass of solvent. So we can use this formula to solve for the mass of solution. So mass of solution is equal to the mass of solute, that's 0.175 grams, plus the mass of solvent, which is 200 grams. And this is equal to 200.175 grams. So this is the mass of the solution. 200.175 times 10 raised to 6. And if you solve this in your calculator, 0.175 divided by 200.175 times 10 raised to 6, this is 874 ppm. And this is the answer to the question. Example 3, what is the ppm concentration of acetic acid in a 0.075 liter aqueous solution that contains 0.500 grams of acetic acid? Acetic acid is our solute and our solvent is water. When you encounter this word aqueous, this means the solvent is water. We are given the volume of solution, 0.075 liters. So we are gonna use the second formula for ppm. So ppm is equal to the mass of solute and the unit must be in grams. In the problem, we are given 0.500 grams of acetic acid. So mass of solute is 0.500 divided by the volume of solution, and the unit must be in ml. And we are given 0.075 liters. So we will convert first liters to ml. So we are using dimensional analysis. 0.075 liters. 1 liter is equivalent to 1,000 ml. So liters will cancel. And this is equal to 75 ml. So the volume in ml is 75 times 10 raised to 6. 0.500 divided by 75 times 10 raised to 6. This is equal to 6,667 ppm. Example 4, the concentration of NaCl in a saltwater sample from the Dead Sea is 280,000 ppm. What mass of NaCl is present in 50 kilograms of salt water? So it's obvious that NaCl is our solute. And we are given the mass of solution, which is 50 kilograms of salt water. So we will use the first formula for ppm. But this time, we are given the ppm, 280,000 ppm. So you put 280,000. This is equal to the mass of solute, which is not given in the problem. So just write mass of solute divided by the mass of solution. We are given 50 kilograms. So put 50, and don't forget times 10 raised to 6. To solve for the mass of solute, divide both sides of the equation by 10 to the power of 6. So 10 raised to 6 will cancel on the right side. And what is left on the right side is mass of solute divided by 50. And on the left side, you have 280,000 divided by 10 raised to 6. This is equal to 0.28. You multiply both sides of the equation by 50. So 50 cancels out on the right side. And what's left on the right side is mass of solute. And on the left side, you have 50 times 0.28. This is equal to 14. And what will be the unit for mass of solute? I told you a while ago that if you are using this formula, you need to be consistent with the unit of mass. So if you read the problem, we used 50 kilograms of salt water. So that's 50 kilograms of solution. So the mass of solute must also be in kilograms. So the answer to this question is 14 kilograms of NaCl. Example 5, the concentration of NaCl in a saltwater sample from the Dead Sea is 280,000 ppm. What volume of salt water in liters contains 500 grams of NaCl? So the problem is asking us for the volume of salt water. So the volume of solution. So we will use the second formula for ppm. This time, we are given the ppm, 280,000. This is equal to the mass of solute in grams. So we are given 500 grams of NaCl. So 500 grams of solute divided by the volume of solution in ml, which is not given in the problem. So just write volume of solution. Don't forget times 10 raised to 6. So we will solve for the volume of solution. Divide both sides by 10 raised to 6. 10 raised to 6 will cancel on the right side. And what's left on the right side is 500 divided by volume of solution. And on the left side, you have 280,000 divided by 10 to the 6. That is equal to 0.28. Next is you multiply both sides of the equation by volume of solution. Volume of solution will cancel on the right side. And what remains on the right side is 500. And on the left side, you have volume of solution times 0.28. Divide both sides by 0.28. So 0.28 will cancel. And what remains on the left side is just volume of solution. And on the right side, 500 divided by 0.28, this is equal to 1786. And what is the unit for volume? Again, as I mentioned a while ago, when you use the second formula, the unit of volume is in ml. So the volume of solution is 1786 ml. But the problem is asking for the volume in liters. So we need an extra step. We will convert 1786 ml to liters. So we do dimensional analysis. We know that 1 liter is equivalent to 1,000 ml. So ml cancels out. 1786 divided by 1,000, this is equal to 1.786 liters. So this is the volume of salt water.